Every year, more than 2 billion Peeps marshmallows are produced, turning these tiny chicks and bunnies into one of the most iconic candies in the United States. So how have these colorful marshmallow treats managed to maintain their place in the candy industry for decades? That journey begins in vast sugarcane fields, where raw ingredients are refined into pure sugar, the very first foundation of the world of Peeps marshmallows. From there, the sugar is transported to Just Born's modern factories, where temperature, pressure, and automated systems work together to create the familiar colorful marshmallow candies. Today, join Agriculture Insight as we step inside these massive production lines to discover how Peeps marshmallows are made, from simple ingredients to an industrial process that operates almost non-stop. The creation of Peeps was essentially a crazy industrial breakthrough. Back when the candy was still produced by the Rada Candy Company, each batch of marshmallow took nearly 27 hours to complete. But after Just Born acquired the company in 1953, Bob Born turned the process into an engineering challenge, cutting production time down to less than 6 minutes and transforming Peeps from a seasonal Easter candy into an American cultural icon for more than 70 years. And once Peeps were no longer just an Easter candy, they began creating an entire trend of their own, eating challenges and speed competitions. What started as a soft, sugary marshmallow tied to a holiday became something people no longer simply enjoyed, but competed to conquer. One champion even managed to swallow 255 Peeps in just 5 minutes to win $1,750. Peeps are basically made from 4 main ingredients: sugar, corn syrup, gelatin, and air. Among them, sugar alone accounts for around 30 grams, or roughly 71% of the weight of a single package. And because of that extremely high sugar content, consuming too many Peeps in a short period of time can quickly turn into an unexpected visit to the dentist, along with a range of other health problems. But to produce the enormous amount of sugar needed for marshmallow production lines like Peeps, the journey actually begins far away from the candy factories, in the vast sugarcane fields stretching across thousands of hectares in the southern United States, where each harvest season marks the very first link in the massive production chain behind them. In the vast sugarcane growing regions of Florida and Louisiana, farmers still burn the fields before harvest to clear away dry leaves, drive out insects, and expose the sugar-rich stalks, allowing harvesting across massive plantations to happen much faster. But along with that speed comes falling ash like black snow, rising PM 2.5 pollution levels, and the risk of weakening the soil's microbial system. That is why every controlled burn in Florida must be strictly regulated according to time and wind direction to prevent fires from spreading out of control. Because of the increasingly visible environmental consequences, many countries are gradually moving away from pre-harvest sugarcane burning and shifting toward a cleaner and more precise method, harvesting fresh sugarcane with modern mechanized machines capable of processing entire fields in just a few hours. The process begins right at ground level, where 2 high-speed rotating blades work like giant industrial scissors, cutting the cane stalks at the exact point where sugar concentration is highest. But even after the stalks are cut from the roots, their journey is far from over. Just above the harvester's cabin, a second set of blades carries out the next stage of processing, rapidly chopping the more than 2-meter-long stalks into evenly sized pieces around 20 to 30 centimeters long. This size is carefully calculated to improve transportation, cleaning, and especially the efficiency of crushing at sugar mills. While the chopping process takes place, a powerful fan system simultaneously blows dry leaves and the lighter cane tops away from the mainstream of material. What may seem like discarded waste actually plays a very important role. as these leftovers remain on the field as a natural organic cover that helps retain soil moisture, reduce erosion, and return nutrients to the soil for the next sugarcane crop. When the cutting process is performed correctly, the remaining cane roots beneath the ground can still regenerate for 3 to 5 consecutive harvests, helping farmers save around 20 to 30% in costs for future growing seasons. As soon as the sugarcane leaves the harvester, the chopped stalks are quickly transferred into a transportation system that operates like a miniature logistics network across the fields. Specialized hauling vehicles can receive dozens of tons of cane in a single trip before transferring it to multi-axle trucks capable of carrying around 40 to 60 tons directly to the factory. This near-immediate transportation speed is a key factor that helps the modern sugar industry maintain stable sugar quality before the cane enters large-scale processing lines. As the sugarcane trucks enter the receiving area, the raw material passes through a large-scale mechanical processing unit positioned at the very beginning of the production line, where massive rotating drums, several meters in diameter, continuously tumble and mix the entire flow of cane. At the same time, high-powered air systems gradually remove the remaining dry leaves left after transportation, creating a more uniform stream of raw material. From there, the cane moves into a high-pressure washing section, where most of the soil and external impurities attached to the stalks are quickly removed, significantly reducing equipment wear and helping maintain consistent raw material quality. After passing through the pre-processing area, the sugarcane is fed into a high-speed cutting unit positioned at the entrance of the crushing line. Here, the stalks are chopped into even smaller pieces to create the ideal material condition for the juice extraction stage that follows. Thanks to this size standardization step, the crushing system no longer has to handle sugarcane stalks over 2 meters long, but instead receives a more uniform and controllable flow of material. Immediately afterward, the material stream enters a series of massive steel crushing rollers weighing dozens of tons. These rollers rotate continuously to compress and crush each layer of fiber through a process lasting around 3 to 5 minutes, releasing most of the sugar stored inside the cane and transferring it into the factory's first raw juice stream before moving on to further processing stages. One notable detail is that the remaining fiber after crushing is not discarded. Instead, it is immediately reused as fuel for the factory's boilers, supplying roughly 70 to 90% of the heat energy needed throughout the production season. After crushing, the raw sugarcane juice still contains many tiny suspended particles, so it cannot move directly to the concentration stage. The liquid is first heated and then transferred into large settling tanks, where dirt and other impurities sink to the bottom and are removed. The clarified juice is then sent to an evaporation system, where it is boiled under vacuum conditions until it thickens into a golden syrup. From here, the syrup is pumped into the cooking stage, where it is further concentrated by boiling under vacuum conditions. This is also the point where small sugar crystals are added to trigger the crystallization process. Once the raw sugar mass leaves the cooking vessel, it is immediately transferred into high-speed centrifuges that spin rapidly to separate the molasses still coating the crystals, leaving behind raw sugar with a clear and stable grain structure. However, the crystals still retain a considerable amount of moisture, so they continue through a hot air drying system where the moisture level is quickly reduced. After cooling, the sugar moves into the refining section for color removal before entering a sealed packaging line. At this stage, the ingredient is finally ready to be supplied to Peeps, where these refined sugar crystals become the structural foundation for hundreds of millions of marshmallow candies each year. And once all the ingredients are in place, the real Peeps production process finally begins. Sugar, corn syrup, water, and gelatin are first heated to around 240 degrees Fahrenheit to create a hot, thick, and uniform marshmallow syrup. The mixture is then whipped at high speed to inject air into it, while the gelatin traps millions of tiny air bubbles, transforming the dense syrup into a light, soft, and fluffy marshmallow mass. Meanwhile, in a separate system, granulated sugar is mixed with food coloring to create colorful batches of yellow, pink, and blue sugar used to coat the candy's surface. Among them, the classic yellow version has remained the best-selling and most recognizable Peeps color for decades. From the mixing vessel, the smooth marshmallow mixture is pumped directly onto conveyor belts, where shaping technology transforms it into tiny chicks and bunnies in an instant. What makes this process remarkable is that the material, still soft and sticky, can be extruded into nearly perfectly uniform shapes over and over again at extremely high speed. This automated molding step became one of the biggest technological breakthroughs, compressing a process that once took 27 hours down to less than 6 minutes. While the surface is still sticky, a stream of air blows colored sugar upward onto the candy, coating it completely and creating the sparkling outer layer that has become a signature of Peeps. As the tiny chicks and bunnies emerge from their sugar coating, sensors on the production line immediately detect their position, so another machine can place 2 edible wax dots as eyes, a tiny detail, yet enough to transform a lifeless marshmallow shape into the instantly recognizable face of Peeps. Right afterward, the candies move onto a conveyor system that removes excess sugar. The remaining colored sugar is not wasted, but collected and fed back into the beginning of the production line. As a result, about 97% of the material is recycled, while the remaining 3% is converted into energy. After being coated in colored sugar, the Peeps chicks are still slightly soft and sticky, so instead of being completely separated, they remain connected in strips of 4 or 5. The signature packaging style that has become an iconic part of Peeps for decades. These marshmallow strips are then automatically arranged into plastic trays by conveyor systems, which keep their spacing and shape fixed to prevent deformation while moving at high speed. Next, the trays pass through a wrapping system, where a thin plastic film is stretched and heat-sealed tightly around the entire product. This process not only preserves the marshmallow's signature soft and fluffy texture, but also protects the outer sugar coating from moisture and air exposure. After sealing, each tray continues through automated inspection systems and metal detectors before being packed into boxes and shipped to supermarkets across the United States. From vast sugarcane fields to marshmallow production lines operating almost non-stop, Peeps are far more than just a simple candy. They are the result of an enormous industrial system working behind the scenes. And perhaps it is this very journey that has turned these tiny marshmallow chicks into a lasting American icon across generations. Founded in 1920 in Germany, the name Haribo is simply an abbreviation of Hans Riegel Bonn, the creator of this iconic candy. More than a century later, from a small, unknown confectionery workshop in Bonn, Haribo has risen to become the world's largest gummy candy empire, with annual revenue estimated at around $4 billion USD. In Germany, Haribo's homeland, the brand holds over 50% of the gummy candy market. From the elderly to children, generations have quite literally grown up eating Haribo, making it not just a candy, but a part of Germany's consumer memory and cultural identity. Compared to other well-known gummy brands such as Albanese in the United States, Haribo does not chase extreme softness or overly sweet flavors, instead remaining firmly committed to its traditional chewy texture, a choice that has shaped the brand's DNA for more than a century. Haribo's success has never been accidental, but rather the result of decades of meticulous refinement and unwavering consistency in product philosophy. Even the colors of its gummies are designed according to precise logic. Red appears most frequently because it is consumed the fastest, while green, yellow, and other colors exist not merely for visual appeal, but to balance flavor, consumption rhythm, and the overall user experience. Beyond that, Haribo continuously updates flavors, shapes, and production technologies to adapt to the demands of each market. So what about you? When you open a bag of Haribo, which color instinctively draws your attention first? And every journey has a beginning. Right now, let's step into the very first link in Haribo's gummy production chain, the gelatin factory, where the foundation of every gummy candy is formed. Each day, a large-scale gelatin factory receives between 50 and over 100 tons of raw materials, primarily animal skin and bones. Upon arrival, the materials are inspected for quality and separated into appropriate processing lines. Before further treatment, all raw materials are reduced in size through cutting or grinding to increase surface area for the subsequent processing stages. After being cut into smaller pieces, the raw materials are soaked and washed in large water tanks, combined with continuous agitation to remove blood, fat, and surface impurities, while also hydrating and softening the collagen structure. This is a crucial pre-treatment step that allows the chemical reactions in later stages to proceed evenly and consistently. In this stage, a large volume of wastewater is generated, containing high levels of organic matter and fats. Therefore, appropriate treatment is required to prevent water pollution and environmental impacts. Next, the materials undergo chemical treatment to break down the collagen structure, typically by soaking in an alkaline lime solution for 5 to 20 days, followed by neutralization with a dilute acid to adjust the pH to around 5-6, preparing them for gelatin extraction. At this stage, the material is heated in water at temperatures of up to around 80 degrees Celsius, allowing collagen to gently hydrolyze and dissolve, releasing gelatin into the solution. This process occurs in multiple cycles, producing a protein-rich gelatin solution that forms the foundation of gummy candy's characteristic elasticity. The raw gelatin solution remains cloudy and contains undissolved particles. To achieve the required purity, it is passed through a multi-stage filtration system with ultrafine ceramic membranes. Under high pressure, microscopic impurities are retained, allowing only purified gelatin to pass through, resulting in a clear, uniform, and stable solution. After filtration, the gelatin is demineralized through an ion exchange system, helping to stabilize its pH, color, and gel strength. Subsequently, the gelatin solution is heated to maintain its liquid state and fed into the vacuum concentration system. The concentration process is carried out at a temperature not exceeding 70 degrees Celsius in order to minimize gelatin denaturation, while excess water is removed to increase the solid's content to approximately 30 to 40%. The resulting solution has sufficient viscosity and consistency for subsequent forming and further processing steps. After the gelatin solution is cooled to a semi-solid state, the elastic mass is pressed through perforated metal plates with precisely controlled openings, forming long, continuous gelatin strands. This extrusion is carried out under stable pressure to ensure uniform strand size and structure, which directly affects the gelatin's solubility and gel strength. As the material passes through the plates, the protein structure begins to set, transitioning from a bulk mass into flexible strands. The strands then fall onto a conveyor belt and are dried with sterile hot air, removing most of the moisture while preserving the protein structure that gives gummy candy its characteristic elasticity. After drying, the gelatin is ground into a fine, uniform powder for easy dissolution and precise dosing. From here, the gelatin is bagged and sealed by batch, ready for immediate shipment to food manufacturing facilities worldwide, as delays and exposure to moisture or temperature fluctuations can reduce solubility and elasticity, directly affecting final product quality. And now, let's move on to the most anticipated part of the journey, where gelatin is no longer just a raw protein powder, but is activated on Haribo's production lines, transforming into millions of chewy gummy candies found on shelves around the world. At Haribo factories, the candy production process begins with the careful selection and precise weighing of key ingredients, such as gelatin, sugar, glucose syrup, water, food acids, flavorings, and colorants. These ingredients are then fed into the mixing system according to pre-programmed formulations, strictly adhering to Haribo's proprietary recipes. From the very first stage, each batch is closely monitored to ensure absolute uniformity and consistent quality across millions of finished candies. After dosing is complete, the mixture is transferred to industrial cooking kettles and heated using high-pressure steam. Under controlled heat, water evaporates while sugar and gelatin fully dissolve. Within just a few minutes, the mixture becomes a smooth, uniform liquid syrup, ready for the next stage of structural stabilization. After cooling, the syrup is tested for bricks using a refractometer to ensure the sugar concentration and consistency meet the required standards before shaping. At this stage, the base syrup is divided into multiple streams for color and flavor blending according to each product. Haribo produces dozens of different flavors, with sour varieties such as cherry, raspberry, and grape, requiring precise acid control to deliver a sharp taste while maintaining gelatin stability. In parallel with flavor preparation, molds are formed directly on the mogul machine using cornstarch blended with mineral oil. The machine spreads and levels the starch, after which stamping heads press the candy shapes into the starch bed, creating hundreds of soft cavities on each tray. The cornstarch not only holds the shape of the candies, but also absorbs moisture from the hot candy mass, allowing it to set slowly and uniformly, an essential factor in developing the characteristic chewy and elastic texture. When the starch molds are ready, the gummy syrup is transferred into central depositing hoppers, where temperature and viscosity are tightly controlled to ensure precise flow. An automated depositing system then dispenses exact amounts into each mold cavity with minimal deviation. Throughout the process, sensors monitor syrup temperature and flow to prevent underfilling, overfilling, or air entrapment, allowing Haribo to maintain consistent gummy quality even at massive industrial scale. After depositing, the trays are stacked and moved into curing rooms for approximately 18 to 24 hours. During this time, the cornstarch continues to absorb excess moisture while the gelatin fully sets, forming a stable, chewy, and elastic structure. After the curing stage, the trays are inverted over vibrating screens, allowing the gummy candies to separate from the starch molds and continue along the production line. The remaining cornstarch falls into a recovery system, where it is cleaned and reused for subsequent batches, improving overall production efficiency. The gummies are then transferred into slow-rotating drums, where they gently tumble and collide with one another as the drums turn. This motion removes any remaining starch residue from the surface, while rounding the edges and evening out the shape of each candy. Once cleaned, a thin polishing layer made from vegetable oil, combined with beeswax or carnauba wax, is evenly applied inside the rotating drums. This coating prevents sticking, enhances surface smoothness, preserves color, and gives the gummies their familiar, dry, pleasant feel. a small detail that plays a key role in the signature Haribo eating experience. Finished gummies are randomly sampled and inspected for shape, color consistency, flavor, and chewiness to ensure each batch meets Haribo's standards. Selected samples undergo additional testing for elasticity and heat resistance, confirming that the gummies maintain their characteristic texture and stability during storage and distribution. Only products that pass all checks proceed to packaging. Finally, gummies that meet quality standards are fed directly from the conveyor into a fully automated packaging system, where multi-head weighing hoppers continuously portion the candies according to precisely preset weights. Each hopper calculates the optimal combination in real time, then releases its measured load straight into individual bags in a split second, ensuring uniform fill levels and minimal variation even at extremely high production speeds. Once filled, the bags are immediately heat-sealed, labeled, and passed through metal detectors to eliminate any risk of contamination. They are then packed into cartons, shrink-wrapped, and stacked onto pallets, ready to enter Haribo's global logistics network. This seamless, end-to-end automated process enables millions of Haribo products to leave the factory every day, supplying retail shelves across hundreds of countries worldwide. Notably, every Haribo gummy is engineered to deliver a chew time of approximately 20 to 30 seconds, significantly longer than fast-melting candies. This extended chewing gradually releases sugar and flavor, creating a smoother sweetness, less taste fatigue, and a consistently satisfying eating experience, no matter where in the world the candy is enjoyed. Few people know that the irresistible appeal of M&M's lies not only in its flavor, but also in a military-inspired idea. In 1941, Forrest Mars Sr., son of the founder of the Mars Candy Empire, teamed up with Bruce Murray, the son of the vice president of Hershey's Chocolate Company. Together, they created a type of candy designed specifically for American soldiers. The name M&M stands for Mars and Murray, the two names behind this sweet alliance. Although originally produced exclusively for the military, M&M's quickly became a sensation after the war ended. As civilians tasted the American soldier's candy for the first time, they were instantly captivated, and the rest, as they say, is history. Another fun fact is that even within a single pack of M&M's, there exists a kind of color discrimination. Not all colors are distributed equally, and that's actually a calculated strategy. If you'd like to know which color gets the most spotlight, share your favorite one with us and join the sweet discovery in this video. Every journey has a beginning, and for M&M's, that beginning lies deep within the lush tropical rainforests, where sunlight filters through dense green canopies and casts golden patches on the trunks of cacao trees. In countries like Côte d'Ivoire, Ghana, and Brazil, where red soil and humid climates create the perfect conditions, cacao trees have been part of farmers' lives for generations. Cacao is a quirky plant. Its pods grow straight from the trunk, and it bears fruit year-round. The main harvest season runs from October to March, when the plantations come alive with the sound of laughter, knives slicing through pods, and footsteps rustling through fallen leaves. Despite being the backbone of a billion-dollar chocolate industry, cacao is still harvested entirely by hand. No machine can match the sensitivity of human touch when handling such delicate fruit. And here's a surprise. It takes more than 400 cacao beans, around 10 to 13 pods, to produce less than half a kilogram of chocolate. That means every tiny candy holds the effort of an entire farm, a whole season, and countless silent hours of labor. After harvest, each cacao pod is split open using sharp machetes or sturdy wooden clubs. Inside the rough, ridged shell are plump, glossy cacao beans, nestled in a layer of white, mucilaginous pulp. This pulp has a mildly sweet, slightly tangy flavor and a fragrant aroma reminiscent of a tropical fruit medley: mango, pineapple, and passion fruit. Immediately after shelling, the cacao beans are quickly gathered into woven baskets, wooden troughs, or wrapped in banana leaves to begin a crucial stage in the journey: fermentation. This is the transformation phase, where bland, odorless beans are turned into the flavorful foundation of seductive chocolate. Over the course of 5 to 7 days, microorganisms in the surrounding pulp generate heat, raising the temperature of the bean mass up to 50 degrees Celsius, triggering a cascade of chemical reactions that unlock the bean's potential. Each day, the beans are turned to allow them to breathe and prevent mold growth, for even a single oversight can turn a batch from richly aromatic cacao to something sour and off-putting, like spoiled pickled fruit. At this stage, the beans are spread out evenly on bamboo mats, concrete patios, or mesh drying racks, and left to dry under the natural sun for several days. During the drying process, farmers must regularly turn the beans by hand or gently rake them to ensure even drying and to prevent mold or continued fermentation. Once dried, the beans are packed into jute sacks, a sturdy, breathable material, ready to be shipped to chocolate processing factories around the world. Each sack holds about 60 to 65 kilograms of dried beans, the result of weeks of careful tending under the sun, the rain, and the hard-working hands of the farmers. Before roasting, some cacao beans are cut open to inspect their internal quality. Inspectors examine the color, consistency, and structure of the inner part, known as the nibs. High-quality nibs should be dark brown, firm, and free of mold or hollow spots. This step is crucial to assess whether the fermentation and drying processes were done properly, ensuring the chocolate produced later meets the highest flavor standards. Next comes the roasting stage, a crucial step that unlocks the full flavor potential of each cacao bean. The beans are placed in roasters at temperatures ranging from 120 to 150 degrees Celsius, depending on the variety, moisture level, and desired flavor profile. During this process, important chemical reactions occur, fully drying the nibs while developing their rich aroma and deep color. If under-roasted, the beans may lack fragrance. If over-roasted, they can turn bitter. That's why each batch must be carefully monitored to ensure the final chocolate achieves a perfectly balanced flavor. Once the cacao beans have been roasted, they are sent to the shelling process. The brittle outer shell is removed using specialized machinery, leaving only the inner nibs. And the magical journey from rough, spiky cacao pods to billions of sweet little candies begins right here. Once the cacao nibs are separated from their shells, they are finely ground under high pressure to form a thick, dark brown paste known as chocolate liquor. Don't be misled by the name. This chocolate liquor contains no alcohol, yet it's more than enough to intoxicate the senses with its rich, pure cacao flavor. After being finely ground into chocolate liquor, the mixture is fed into a hydraulic press. Under immense pressure, cocoa butter, the rich, creamy essence of each bean, is slowly extracted, dripping out in golden drops like honey. This is the step where the purest essence is drawn out, giving chocolate its irresistibly smooth, melt-in-your-mouth texture. The remaining material after the cocoa butter is extracted, known as cocoa cake, is cooled and then transferred to a high-powered grinder. Here, the cake is finely ground into cocoa powder, preserving its rich aroma and characteristic bitter taste. This powder is a common ingredient in baking, beverages, and is used to add flavor to many other chocolate products. Later, the cocoa butter is blended back together with chocolate liquor, sugar, and other essential ingredients to create a smooth, aromatic chocolate mixture. It's a process where each step is a blend of science and emotion, so that when chocolate touches your tongue, you're not just tasting sweetness, but experiencing a whole journey. The liquid chocolate is poured into cold, round, or hemispherical molds to shape each chocolate center. The mixture quickly solidifies while maintaining a smooth and glossy surface. Afterward, the chocolate pieces are placed in a gentle rotating chamber to help them become more evenly shaped, remove air bubbles, and set firmly. This is an essential step in creating a smooth center, ready for the sugar coating in the next stage. The mixture of thick syrup, glucose syrup, and other ingredients is used to create a smooth and shiny coating. This mixture is sprayed into a large rotating drum, where the chocolate pieces continuously roll around. Inside the giant rotating pans, the chocolate centers continuously tumble as the coating mixture is gently sprayed in. Thanks to the constant motion and alternating drying process, the mixture gradually dries and adheres evenly to each piece. With every turn, a thin layer of sugar forms, followed by more spraying and drying. The result is a crisp, glossy, and perfectly smooth shell, one that prevents the chocolate from melting and delivers that satisfying crack with every bite. M&Ms not only delight the taste buds but also stand out with 6 signature colors: red, yellow, green, blue, orange, and brown. Among them, blue and orange are favored for their positive vibe and appetite-stimulating effect. In contrast, brown, despite resembling the color of chocolate, appears the least to ensure each pack stays vibrant and eye-catching, which has long been the visual trademark of M&Ms. But the journey of each candy doesn't end with its crisp sugar shell. After being coated in vibrant colors, each M&M enters a final iconic step: the printing of the M logo, a tiny yet powerful mark that transforms an ordinary chocolate piece into a global star. And so, after all the meticulous steps, the brightly colored candies finally roll into their final stop, the high-speed packaging line. Thousands of M&Ms are poured into the automated system, where they are perfectly portioned, sealed in small packs with a printed code like a passport, then swiftly placed into awaiting cartons. From here, the national candy begins its adventure, appearing on supermarket shelves, in theater snack counters, in convenience stores on street corners, and even in space. Who says candy is just for eating? With M&Ms, each piece is a vibrant personality, a cartoon character stepping out from imagination to become the very soul of the brand. Since the 1990s, M&Ms has breathed life into each color, turning them into beloved icons of global pop culture. Yellow is innocent and kind, while red is confident and proud. Green is alluring and sharp, and Ms. Brown is intelligent and composed. Blue exudes calmness and coolness, while orange is always anxious but sincere and lovable. Each color tells a story. Each candy embodies a way of life. If you're a fan of M&Ms and want to explore a world full of colors, M&M's World is the place you can't miss. While you're here, don't forget to check out the M&M's Wall, a 50-meter-long candy wall with hundreds of colorful candy tubes, where you can pick your favorite colors or mix and match to create your own cool combo. You can even print your portrait or a personal message on an M&M's candy, creating a super unique souvenir. Additionally, M&M's World offers exclusive souvenirs like t-shirts, mugs, and stuffed animals, all available only here. Let's take a quick trip back in time. The M&M's logo first appeared in 1941 with a simple typeface. In 1954, the iconic lowercase m was printed on each candy in black ink, later changed to white for better visibility. During the 1980s, the logo was softened with rounded edges to match a more youthful image. Since 2000, M&M's has continuously refined the design to stay modern and vibrant, while keeping the brand's playful spirit alive. Born in 1964, from the idea of reusing leftover tortillas at a restaurant in Disneyland, Doritos quickly became a global icon of corn-based snacks, made from an ingredient more associated with Mexican cuisine than the food industry. With over $4 billion in annual revenue, Doritos is the best-selling corn snack in the world, available in more than 70 countries. In the US alone, it holds nearly 20% of the savory snack market. Second to Lay's in volume, yet leading in bold flavor and strong personality. Unlike light and airy potato chips, Doritos are crispy and dense, coated in charred cheese flavor with a hint of smoky roasted corn, delivering a heavy hit of taste from the very first bite. However, just half a bag of Doritos contains nearly 40% of the recommended daily sodium intake, about 3 times that of a regular serving of potato chips. Doritos has not only shaped global snacking trends, but also revealed the fine line between health and our dependence on flavor. So, how many bags of Doritos could you eat in a year? Before becoming the crispy golden chips inside every bag of Doritos, each corn plant goes through more than 4 months of meticulous care, from the moment the seeds are sown until the ears fully mature. Then, as autumn arrives, vast cornfields stretching for hundreds of hectares awaken to the thunderous roar of giant combine harvesters working tirelessly day and night. These machines are truly the heart of modern harvest season. Equipped with ultra-sharp stainless steel blades, they can automatically adjust their cutting height according to the terrain and plant size, ensuring precise cuts at the ears without damaging the stalks or losing kernels. Once cut, the corn ears are drawn into a sealed processing chamber, where gears, air blowers, and vibrating sieves work in perfect harmony to remove husks, silks, and stems, leaving each ear in its optimal condition. Immediately after harvesting, the corn is unloaded directly onto specialized trucks and transported to the factory in the shortest possible time. Thanks to modern technology, each harvester can process up to 140 tons of corn per day, drastically shortening the harvest period while preserving the freshness, sweetness, and natural starch content of every kernel. These qualities form the foundation of the smooth, elastic masa dough that gives Doritos their signature golden crunch. After leaving the fields, trucks loaded with golden corn ears line up and head toward the factory. Each massive truck bed is tilted to pour the corn onto outdoor conveyor systems, where thousands of tons of raw material begin their next journey. The entire area operates like one giant machine. Bulldozers, conveyors, and air blowers working non-stop to evenly distribute the corn and keep the flow of material smooth and uninterrupted. From here, the corn is sent into the processing zone, ready for the next magical transformation, from raw kernels into soft, elastic masa dough, the very foundation of the legendary Doritos snack. As the corn travels along the conveyor belt, its first journey inside the factory officially begins. Each ear of corn passes through a high-speed husking system, where rough-surfaced rollers spin thousands of times per minute. Within seconds, the dry husks and silks are completely removed, without scratching or cracking a single kernel. Immediately after, the corn enters the kernel separation chamber, one of the most crucial stages of the process. Inside, 6 ultra-sharp steel blades operate in perfect synchronization at high speed, slicing the kernels off the cob with such precision that almost none are lost. Smart sensors automatically adjust the spacing between the blades, ensuring flawless performance regardless of the size of each ear. This production line can handle up to 6,000 ears per hour, creating a mechanical rhythm that's both powerful and precise. Right after the kernels are separated, streams of golden corn are directed straight into the cleaning system. Here, the kernels pass through a series of vibrating sieves, where controlled airflows and rhythmic shaking work together to remove dust, small stones, and fine sand. Then, they are thoroughly washed in high-pressure swirling water tanks, leaving each kernel gleaming and pristine as if freshly awakened. Next, the corn enters a specialized rotating drum that peels off the outer layer while removing any kernels that are too small, too large, or broken. This step ensures even cooking and lays the foundation for producing high-quality masa dough. Once cleaned and meeting quality standards, the corn is directed straight to the cooking area, where the real transformation begins. Giant mixing kettles cook the corn at around 190 degrees Fahrenheit, 88 degrees Celsius, for about 4 minutes, with a ratio of 660 pounds of corn to 20 pounds of water in each batch. This softens the kernels and breaks down their internal structure. The cooked corn is then transferred to 18 open soaking tanks, where it continues to absorb water for several hours until reaching the ideal moisture level. After soaking, the softened outer skins float to the surface and are removed, leaving only the pure kernels. The corn stream is then directed into an automated washing system, where high-pressure water jets and swirling tanks continuously clean and flush away any remaining husks or impurities. What's left are moist, smooth, and gleaming kernels, perfectly prepared for the grinding stage, where they will be transformed into a uniform, refined masa dough. The corn then enters the grinding stage, where it's crushed between two rotating alumina stones. At this point, about 20% white corn is often added to improve cohesion and create a smoother texture. Here, 3 key parameters are strictly monitored: temperature, moisture, and fineness of the dough. Even a deviation of just 1% in any of these factors can ruin the masa's life, its elasticity, and its ability to form that perfect crisp and airy texture after frying. From this masa, every Doritos chip is born with the same DNA, a perfectly balanced dough formula that Frito-Lay has kept secret for decades. Continuing down the production line, the perfectly prepared masa is pressed through metal rollers to form thin sheets, which then pass through a triangular cutter, capable of slicing up to 6,000 pieces per minute or more than 8 million chips per day. Immediately after, the small dough pieces are baked in a 3-tier high-temperature oven for 16 seconds. Just enough time to dry the surface while keeping the core slightly moist, ensuring the chips remain flexible yet structurally intact. This process is what creates the tiny air bubbles on the surface of Doritos, the hallmark of that perfectly crisp signature texture fans love. To achieve the perfect crispness without burning, the cut chips are fried precisely for 55 seconds. During this time, the air bubbles expand one last time, creating that light, airy, and irresistibly crunchy texture. As soon as they emerge from the oil, the chips are drained of any excess oil and prepared for the seasoning stage, where the true soul of Doritos awakens, giving them their unmistakable flavor that sets them apart from every other snack out there. Before seasoning, Doritos chips are lightly sprayed with canola oil to help the coating stick, then sent into a massive rotating drum, where cheddar, parmesan, and a blend of spices are evenly dusted over each chip as they tumble gently against one another without breaking. In that moment, the rich, creamy cheese blends perfectly with the corn's natural sweetness, creating the bold, crispy, and irresistibly addictive flavor that defines Doritos. From this iconic base, the brand has expanded to more than 20 different flavors, from fiery barbecue to versions inspired by Mexican street food, transforming Doritos into a global symbol of creativity and bold taste. And after all those transformations, the Doritos journey inside the factory comes to an end on the cooling conveyor, where a burst of cold air quickly locks out moisture to seal in that signature crunch. At the packaging area, fully automated 14-head weighers ensure each bag reaches the exact target weight, with smaller bags holding around 28 to 30 chips and larger ones about 140. Before being sealed, nitrogen gas is pumped into every bag, not only to remove oxygen and keep the chips crisp for longer, but also to create a cushion of air that protects each piece from breaking during transport. From here, Doritos leave the factory floor and blend into everyday life, appearing on dining tables, in snack bags, and home kitchens, inspiring endless culinary creativity. In Mexico, Dorlocos is a famously crazy street food, with Doritos as its soul. Crispy, cheese-coated chips mixed with vegetables, candy, lime, chili, and pork rinds, creating a bold symphony of spicy, tangy, sweet, salty, and rich flavors. For just 30 to 50 pesos, you can taste the vibrant spirit of Mexican street food. And behind every crunchy bite lies a story of fusion between Mexican craftsmanship and American technology, where tradition is reborn as a global snack icon.